Alright guys, so standard 15 is all about the unit circle, and then all the trig values connected to the unit circle. So it's not that hard. Like, it's really not. There's a lot of patterns. I think it'll make sense to you. We spend 3 days on it just because it's so important. If you don't actually know your unit circle, everything else that we do in trig is just that much harder. Okay, so you what?
The class is called pre-calculus trig.
Welcome to trig. Okay, so on that note, all right, what we're going to do is kind of break this down by the special right triangles and work our way around the whole circle. So we're going to start in degrees because that's comfortable for you guys. So over here on the right is 0 degrees. Okay. What would it be if I went all the way around the circle? 360, okay. So what is it going to be on the left side over there, halfway around the circle? Okay, we know that. What about up at the top? 90. And then if we went straight down to the bottom? 270, okay. Those are your quadrantal angles. We'll look at those a lot. We'll label those in every single one of these that we do. What we care about in this first one, though, is what's going to happen in between. So in that first quadrant, what is halfway between 0 and 90? 45. 45 matters, right? Special right triangles with 45, 45, 90. Okay, so we're going to label this all the way around. So you guys see how from 0 to 45 is 45 degrees. And then if I add 45 degrees, I get to 90. If I add 45 again, where will it be? 135. All right, then I'm at 180. What's going to come after that? Then I'm at 270. What's after that? 350. All right, are we good so far? That's not tricky yet, right? Okay, hopefully it stays that way. All right, that's in degrees. We're also going to do this in radians. So we're still talking about 45 degrees. Over here where it was 0 degrees is also 0 radians. Do you remember what it was if you went the entire way around the circle?
2 radians.
2 pi radians. Yeah, okay. It is 360 degrees, but we're in radians now. This is a new circle. Like, I'm on the bottom, right? We did that. I'm down here.
So what's next to 0?
2 pi.
So then on the left would just be pi?
On the left would just be pi. Good. What's going to be at the top then? Half of pi, which is pi over 2, yes.
Oh.
And what about at the bottom? Not 3/4 pi, because that's actually less than 1 pi. What's in between 1 pi and 2 pi? 1.5 pi, yeah. So we write that as 3 pi over 2. Everybody knows 3 over 2 is 1.5, right?
Yeah.
Maybe. It's a good day, Chris. Okay, so again, those you're going to see over and over and over. We need to figure out the halfway point. So where 45 degrees was, what is 45 degrees in radians? You can either convert it or what's halfway between 0 and pi over 2? Quarter pi, yeah, so pi over 4. All right. You could add pi over 4 all the way around over and over, but that's kind of annoying and tedious. So we're just going to look at the pattern. All right, this is 1 pi over 4, right? Okay. 2 pi over 4, what does that reduce to?
Pi over 2.
Okay, so that's here. So 1 pi over 4, 2 pi over 4, what's this going to be?
3 pi over
3 pi over 4.
4 pi over 4, and then we get 5. 5, and then we get 7.
Okay, you guys are on a roll. This is really 4 pi over 4, so this one is 5 pi over 4. You're basically looking for the over 4s that don't reduce. And then fourth quadrant, what's that going to be?
5.
Third quadrant was 5 over 4. What's fourth quadrant going to be? 7 over 4. Okay, let me stop there for a second. Does that make sense? With me so far? Right? Not bad yet? Okay, keep going. Anybody need more time? Okay. All right. We have other special right triangles, right? 30, 60, 90?
Good.
Okay, so we got to use those also. We're going to start the exact same way. We're back to degrees now, guys. So 0 degrees is over here. What's next to it?
360.
360.
360.
What's at the top? 90. What's on the left? 180. And what's at the bottom? All right.
30.
30 is going to be the next one we're talking about, right? So this is 30. Okay, what do you think the next one after that's going to be? 60. All right, so we've gone 30, 60, 90. What's next? 120. After 120 is 150. And then we have 180. What's next? 210. After 210 is 240. 270 is there. After that, 300. And your last one. Okay. Still not bad, right? Okay. We do have to think about these in terms of radians now. So I'm going to use actually I'll use 3 different colors. Maybe before lunch we can squeeze in. We know this is 0 and all the way around is 2 pi. What's at the top? Pi over 2. Okay, we'll continue after lunch, guys. All right, so pi over 2 is at the top. What's going to be over on the left? Pi. You guys didn't forget everything at lunch, did you? Maybe. All right, what's at the bottom? 3 pi over 2. Okay. All right, I'm going to use a different color. I'm going to go to green. Okay, that green dot, that is where 30 degrees was. What is 30 degrees in radians?
130. 130.
There's no square root needed yet. Radians, like with pi.
1 over 3 pi.
How many times does 30 go into 180?
6.
6. How many times? We're talking 30 degrees, right? How many times does 30 go into 180? Pi over 6.
Oh, yeah.
Okay. So this is pi over 6. All right. Can you guys see the green dots that I'm doing on here? The ones closest to the x-axis? Those are all connected. Do you guys see how they're the same distance from the x-axis? I know 2 of them are up, but then the other 2 are down. They all have something over 6 as their radius. Okay, the way you figure this out, you can start counting your way around the circle. What we're looking for is basically a non-reducing fraction. So this is 1 pi over 6. Next is 2 pi over 6. But does that reduce? Okay, so I don't want that one. What about 3 pi over 6? That reduces, I don't want that. 4 pi over 6 reduces 5 pi over 6. Okay, that's 5 pi over 6. And it should make sense. You're 5/6 of the way to pi. Okay, then keep going. So do I want 6 pi over 6 for the next degree?
7 pi over 6.
7 pi over 6. Good. Well, that'll reduce. That's actually the bottom there. 3 pi over 2. So what do you think? What's our last one going to be? 11 pi over 6. All right, so that's all the over 6s. Okay. I'm changing colors again. So now we've got these pink ones left to do. All right, that's 60 degrees. What is 60 degrees in terms of radians?
Pi over 3.
Yes, that one is pi over 3. All right, so then it's the same process all the way around. That was 1 pi over 3. What's the next one going to be? 2 pi over 3. Do I want 3 pi over 3? No.
You already have regular pi.
Good job. What's the next one that I want?
You want, well, you already have 7 pi over 6, but then you go 4 pi over 3.
4 pi over 3. Yeah, we're doing all these over 3. All the pink ones will be something over 3. So then what's the last one?
5 pi over 3.
Yes. Okay. Does that make sense where all of those, like the pattern, you could follow your way around the circle? Okay. Questions so far? All right. We're going to put it all together on here now. I am going to do this in 4 different colors. If you have colored pencils, colored pens, something, I would get them out. I'm going to use red, green, blue, and pink, but you use whatever works for you. I'll give you a second. If you have them, get them out. All right, guys, I'm going to start in red and do my quadrantal angles. Let's go ahead and do all the degrees first, and then we'll come back and do all the radians, okay? So I know 0 degrees is over here. What's up at the top? 90. On the left? 180. Down at the bottom? 70. And all the way back around? Okay. I'm going to go ahead and just fill in this first quadrant. We know the first angle is 30, right? The second one would be 45, and I'm switching colors each time, guys. I know it's kind of annoying. And then the top one would be 60. You can either think through like all of the 45s and then all of the 30s, or you can just work your way all the way around the circle counting. You guys see this pattern, how it's 30 degrees away from the axis, and then it's 15 degrees, 15 degrees, 30. Okay, so then we'd have another 30, 15, 15, 30. Does that make sense? Okay. So what are those second quadrant angles going to be? What's the first one at the top there, towards the top?
120.
120, so I'm making that pink. What's in the middle? 135, that's blue for me. And what's the last one in the second quadrant? 150. All right, I'll wait a second. I know using colors makes it take longer, but it helps a lot. Bless you. Are we okay with the second quadrant? Okay. Into the third quadrant. Green will be the first one. What's that going to be for me? 210, good. What's in the middle, which is blue for me? Excellent. And the last one in the third quadrant, which is pink. You're on a roll, Phil. Anybody questions on the third quadrant? Hey, at least you're doing well with the angles, right? Okay. All right, fourth quadrant. Pink would be the first one. What's that going to be? 300, yeah. What'll be in the middle? 350. And then the last one in there. Getting 330. All right, so degrees. If I said, hey, fill in all the degrees on the circle, could you do that? Yeah, okay, that's not bad, right? Okay, let's look at our radians now. Let's do all the red ones first, so all of the quadrantal angles. So 0 degrees is also 0 radians. What's up at the top?
Pi over 2.
Pi over 2. So I'm sticking with red for all of these. What's on the left? Pi. What is at the bottom? Good. And all the way around? 2 pi. All right, not bad, right? Okay, I'm going for the middle one, the blue one. All right, so what was 45 degrees? Yeah, I'm doing 45.
Oh.
It's halfway between 0 and pi over 2, right? Halfway, like, this is 0, this is pi over 2, right? What's halfway in between? I'm going to the middle one. Pi over 4, yeah, so we're going to do all of the over 4s. I know some of you said that earlier, but... So every blue one, I'm just going to say, okay, over 4, over 4. And then all I have to think about is what the numerator is going to be. Quadrant 1 was pi over 4. What's quadrant 2? What did you say, Jack? Good. 3 pi over 4. Just count, guys.
Wait. What was the one? That's 270.
3 pi over 2. All right, what about 225? What's that going to be? 5 pi over 4. Good. And your last one. All right, I'm switching to green. I'm doing the 30-degree angle. What is 30 degrees in radians? Pi over 6. Good. So all of my green ones are something over 6. Remember, we want a non-reducing fraction. That's what we're looking for. So what's the one in the second quadrant going to be? 5 pi over 6. Here, I think you get the next one. 7 pi over 6. Good. What about fourth quadrant? 11 pi over 6. Good. How are we doing, guys? We're seeing it? Yes. Okay. All right, 60 degrees. What will that be? Our last one. Pi over 3. So the pink ones are all something over 3. So what will the second quadrant be? 2 pi over 3. What about third quadrant? yes. And then your fourth quadrant one. All right, let me stop there for a minute. Anybody questions on any of it? Please ask if you're like, I don't have any idea why they're color coded, or I don't know what you're doing with the fractions. Like, ask me if you're stuck on some part of it. Okay. Chris, you look like you have a question.
What?
You looked like you had a question. Okay. Yeah, keep one out, okay.
What?
All right. Anything, anybody? Okay, do you notice that there's still blanks on here? Right? Okay, we got to fill those in too. So what we are looking at is called the unit circle. It's because the radius is 1 unit long. Okay? So all the way around the radius is 1. So we're going to do all the red ones first, the quadruple ones. So if the radius is 1, what is the ordered pair of that point? 1, 0. Over 1, up and down 0, right? Yes, I'm still color coding. What about at the top? What's that going to be?
0, 2.
No. 0, 1. Yeah, the radius is 1 all the way around. So in this point in the center, that's still, 0, 0 if you were to graph it that way. Okay, so what will it be on the left? Negative 1, 0. And at the bottom? Okay. All right, so those aren't bad, right?
How are those at 4?
Oh,
okay.
yeah, I don't know. The parenthesis thing is weird. That is negative 1, 0. Yeah, that would be really wrong if it was a 4. Let's try to.
Oh.
You guys see how what's on there is just weird? Is that better? All right, let's think about our blue ones now. So guys, I'm going to go back here. If we're looking at a 45, 45, 90 triangle, hopefully you remember things about special right triangles. Since we're on the unit circle, we know that this hypotenuse here is 1. So I'm going to do that on the little triangle over here. I need to figure out x and y. So yes, I flipped back to the first page here, guys. Do you remember how to find missing parts of special right triangles? Okay, so 45, 45, 90. Remember, it's hypotenuse equals root 2 times a leg. So how am I going to find x or y? Divide by root 2. So I get 1 over root 2. And that is root 2 over 2. And that's both the x and the y. Now I labeled it with x and y on purpose. Sideways, horizontal, that's the x. Up and down is the y. So if you wanted to write this as an ordered pair on your circle, what would you write?
Root 2 over 2.
Exactly. So let's think about it. If I look at all the ones I have in blue here, what is the only thing that's going to change from quadrant to quadrant for those? The signs. Okay, so in the second quadrant, I'm still using the root 2 over 2, but what is the actual point going to be? Which one's negative? Yeah. So you have negative root 2 over 2, root 2 over 2. What's going to happen in the third quadrant? Both negative. And in the fourth quadrant, negative y. So it's going to be root 2 over 2, negative root 2 over 2.
What's pi? So it's always pi over 2, and then it just depends on what you call it, quadrant. Wait, is that pi or is that square root of 2?
That's root 2 over 2.
Oh!
Remember here? Like, yes? Right? With me?
Oh, yeah. No,
Yeah,
that's
okay. All right. Yeah. The pies are the angles. They're never the, like, the coordinates.
Okay.
Okay.
That's good.
All right. Sorry. Downside of sitting in the back.
Yeah.
Do you see it okay? Kind of. So if you know the first quadrant ordered pair, you know all 4 of them.
Yeah,
Okay.
you just change the constant.
Yeah, you know that. It all comes together. I'm glad you appreciate it. All right. We've got to do the remaining 2 special right triangles. So let's look at 30 degrees first. So here's my 30 degrees. Again, the radius is 1. That's the hypotenuse. And I've got an x and I've got a y. So which one's actually the short leg?
Is that
Y.
H?
What?
That's H or
This is a page. Yeah.
H. H.
An H? Oh, I thought you said a page. I'm like, yes, this is a page in your packet. An H. I don't see an H.
What's the thing above that X? That's an R, bro. That's an R. What are you looking at?
What's the hypotenuse? Like, what is this?
How long is the hypotenuse in a unit circle? Is that what you were talking
Oh,
about?
that's 1? Oh, 1.
Guys, how long?
Having a day.
Wow, so glad I'm recording today. How long is that piece from our circle, right? 1. Okay. Are we all on the same page? Okay. I think you guys might have had the highest average on the quarter though, so definitely my liveliest class. All right. So we know the y is going to be 1/2 then, right? Because it's the short leg. Short leg's always half the hypotenuse. What is the long leg going to be then? Root 3 over 2. Remember, short leg times root 3 is long leg? That's stuff you've learned, you have to remember, okay? So that's root 3 over 2. Okay with that? So the ordered pair is root 3 over 2, comma, 1/2. And guys, I don't memorize this. I look at it and I go, okay, x is clearly longer than y. Like if I'm trying to travel from the origin, you go over a long way x and then a short way on y, right? So I know x has to be the long part and y has to be the short part. Okay. All right. So do you know all the green ones now?
Yeah.
Wait, that's a 3.
It's root 3 over 2
Wait,
and
so
1/2.
how'd you get 1/2?
Okay, so in a special right triangle,
Oh, that, okay.
can you remember hypotenuse
Oh, yeah, yeah, okay.
is 2 times the short leg, long leg, root 3 times short leg, yeah? Remember that stuff? It's the unit circle, meaning 1 unit. So it's only in the unit circle that these are the exact values that you get. All right, so this would be negative root 3 over 2, 1/2, both negative. Okay. All right. One more to go, guys. Yeah.
This corresponding to sine.
We're going to talk about that. Sine ends up being your y value because opposite over hypotenuse, cosine adjacent, exact value. So we'll get there. This is why we spend a lot of days on this standard. All right, so now if we think about the 60-degree angle, your hypotenuse is still 1. Here's the x and here's the y. What? Yeah.
This circle gets greater than just 1 unit each square, right?
No.
No, it doesn't.
Mm-mm.
Like, will we do ones that do or no?
Everything connected back to the unit circle is always just 1. So all the trig values we deal with related to it are just, so yeah. Yeah.
Never mind.
You sure?
Yeah, I'll skip it.
Okay. All right, guys. So if we're looking at the 60-degree angle, which side is the short leg now? X. So how long is X going to be? Half. How long is Y going to be? Root 3 over 2. Do you guys see it's the exact same values, right? They're just switched. Okay. And again, I do not memorize that. I look and I go, okay, I'm going sideways not very far, and then I'm going way up here. So I know it's short leg for the X, long leg for the Y. Okay, so it's going to be 1/2, and then root 3 over 2. Second quadrant, we know it's -1/2, root 3 over 2, -1/2, negative root 3 over 2, root 3 over 2. Okay. Questions? That is the entire unit circle. So guys, I'm giving you the answer key to an assessment on the unit circle. That's it. Okay. So, we won't do it next class. We'll do it the class after that. You'll have 10 minutes, and I'll give you a blank circle, and you have to fill it all in. Okay?
I'll just stare at it all weekend.
Stare at it all weekend. So what we're going to do right now is just practice that, because you probably know way more of it than you think you do. So, turn the page. I know. I'm going to put 10 minutes up here. Fill in as much as you can. Ready, go. This is not like real for a grade, but just so you have a feeling of what 10 minutes is like.